Good morning, everyone. Let us wait for a few minutes for
Good
others to
morning.
join in. Good morning, Anand. And then we'll get started. As this is the first class for many, we'll just give it another couple of minutes and we'll start sharply at 8:35. Okay? Thanks everyone else for joining on time. Really appreciate it. Okay, good morning, everyone. Thanks for joining in. We are a bigger group now, and I really appreciate all your commitment and effort to learn these data center technologies. So, this will be an intermediate level course. Why it is intermediate? Because apart from learning theory and concepts, we will be learning about practical scenarios and how to do stuff. Okay. Uh, it's not just all theory. So this 1.5 hours, 8:30 to 10, Monday to Friday, we are going to divide it only 30 minutes for theory or conceptual knowledge. Okay, the rest 1 hour we will allocate ourselves to learning hands-on techniques and practicals. Okay, few things I will show you in my system, okay, by sharing my screen, and I will give you some practical classes to be done at your own, leisure and convenience. Okay, and the concepts that we are going to touch in the next few weeks are: one is definitely Linux, Red Hat Linux, particularly. Okay, then Windows servers, Microsoft Windows servers, server administration. Then we'll learn about hypervisors, which are the basic concept for virtualization and cloud. So we will know how to install hypervisors. We will know how to deal with them. Okay, at a small scale right now. And whenever we find an opportunity of helping you with a real-time customer scenario, we will involve you in such activities. Okay, so that you can get hands-on, training. Then apart from hypervisors, then we will get into actual application workload. So the operating system and the hypervisor form like the base or foundation of any data center work, infrastructure. And over and above that, we are going to learn a few applications which are also critical uh, for running and operating a data center. So the first among them, we are going to learn about backup software. Backup software is what is needed to protect data, which is there inside your laptop, your phones, your uh, servers and devices and virtual machines. And we will learn 2 to 3 different backup softwares. So we will learn about Commvault, we'll learn about Acronis, and we'll learn about Rubrik. Okay, so I will teach you how to install them, what are the concepts behind it, what are the architecture on which they are built, and as much as possible, I will try to give you hands-on labs, okay, so that you can practice it at your own, convenience. And apart from backup software, we will also learn about an open source network monitoring software called Zabbix. Okay, how to install Zabbix, how to integrate it into a data center environment, and all these things. Okay, so that is what we will learn over the course of next few weeks. Some ground rules, because we are a larger group. Okay, a lot of you may have questions, and a lot of you may have doubts. For many of you, this may be the first time you're encountering or dealing with such technologies. So it's okay to have questions and doubts. So there is a Q&A button on the top, you will see. Okay. And you can open it and you can put your questions in the Q&A box. And I will, do my best to answer them immediately or after the class. Okay. So feel free to do that. Even while you are doing your practicals, if you have any questions, post it in the WhatsApp group. Okay, we do have certain experienced people also part of this group. So either me or this group of experienced people, we will help you with answers, as well as we will help you with learning resources. Now what do I mean by learning resources? basically YouTube links where you can watch and learn how to do it, or documentation or presentations and things like that. Okay. And even after following that, if you're not able to, rectify the problem or clear your doubt, definitely we can help you offline. Okay. So no question is a stupid question, and there is no right or wrong answer in these classes. Okay. Please feel free to express yourself, and please feel free to gather as much knowledge and experience as you can. Because let me tell you one thing, no two data center environments or no two customers are the same. Okay. Just because you may have learnt how to install or configure a particular kind of technology in a particular customer environment doesn't mean that it will work the same way or it is configured the same way in another environment. No. Okay, the way it gets integrated into a customer environment may be entirely different. Yes, you will have a basic idea of how to do many of the things, but exact configuration, it will not be the same. One more thing is, while we are working on these technologies, right, Linux, Windows, hypervisor, backup software, and network monitoring software, we will also touch upon concepts related to networking as well as cybersecurity. Okay. So please feel free to ask any doubts, and we will be referring to lot of study and course materials pertaining to these concepts and technologies. Okay. We still have people joining in. Okay. So before we get started, uh, can all of you confirm on what I had Anand, I have enabled recording the moment the meeting starts. So I learned from my mistake. Yeah, some of the one of the previous class I forgot to record. So that's why Anand was reminding us. Thanks, Anand. So we were going to turn your laptop into your lab. Okay. Hey, that's okay, Anand. No need to be sorry. Uh, and for that, we have multiple options. One is to use a hypervisor called Hyper-V, but that will work only if you have a Windows Pro or a Windows Enterprise Edition. So can all of you confirm that if you do you have a Windows Pro or Windows Enterprise on your laptop, 10 or 11, version 10 or version 11? You can just give a thumbs up. Okay, Anand says no. How about others? Windows 10 or Windows 11, Pro version or Enterprise version on your laptop. You're not able to hear. Venkat, please check your audio settings on Teams. You should give permission if you're logging through browser to this application so that it can use your speakers and uh, camera. Okay, Shamba Sivrao, you have Windows Pro or Enterprise. Good. So you can use Hyper-V. You can just follow the instructions which I put in the WhatsApp group yesterday. Okay. For others who do not have Windows 10 or Windows, uh, Pro or a Windows Enterprise Edition, Gopi, thanks for the confirmation. Okay, what we will do is we will use an open source hypervisor called Proxmox. Okay, it's an open source hypervisor alternative to VMware. It's called Proxmox. Okay, I'm putting the name in the chat. So no need to experiment now. Okay, I will give you exact instructions on how to install it. But It is free, okay? No cost to that software. Unlike Windows Pro or Windows Enterprise from Microsoft, which is costed, Proxmox is not chargeable, okay? It's a completely free. So I'll also give you the software to be downloaded, okay? I have it with me. So what we were going to do is, what you have to do is, you have to buy a brand new USB stick or USB 2.0 or USB 3.0 stick, okay? Pen drive. Why we need that? We are going to load that Proxmox software into that pen drive, and that pen drive or USB disk should not have any other data on it because it will get wiped out in the process which I'm going to teach you. Okay, how to install Proxmox. Okay, so you have to buy 64 GB or higher pen drive, and we will use that pen drive as a bootable disk or a bootable drive to make sure that your own laptop, on your own laptop, we can install something called as a Proxmox hypervisor. And on top of that hypervisor, we are going to have a Linux virtual machine and a Windows virtual machine, so that whatever labs I'm going to give you, you don't have to go and buy the labs or spend any money apart from buying that 64 GB pen drive or hard disk, which hardly I believe is a few hundred rupees. Okay. So please make this investment. It is going to be extremely useful for you in the long run. You can actually, using that pen drive, convert any system in the world, okay? Any system in the world, irrespective of which operating system it has, okay? You can convert that into a Proxmox machine and start creating virtual machines on it based on the hardware resources that are available. So it's a very powerful software, yet at the same time very easy and simple to use. But in order to use Proxmox, you know what you have to learn? You have to learn Linux, okay, or any version of Unix, and that is what we are going to start now. Okay, so confirmation, all of you are able to hear me and see me. Just give me a thumbs up. Thanks, Shivani. Thanks, Satvika. Thanks, Gaurav. Thanks, Banu. Okay, I get it. Yes, thanks. Thanks, guys. Thanks, Krishna. Great, great, great. Okay. Now I'm going to share my screen, and just for 25 to 30 minutes, we will do small theory about what is Linux, okay, what is its origin, uh, and some basic concepts about Linux. And then guess what? We'll go straight into the lab, okay? And I will show you, without even installing Proxmox, how to get a free lab, okay? But because it's free, there are some conditions and constraints, and we will see what they are. But that free lab will help you to practice certain Linux commands, okay? And the exercise or the lab exercise at the end of the class, which you have to do after the class, okay, is whatever we are learning the concept and commands in Linux, you should be able to understand that concept and perform the same thing on your Windows laptop. Okay, don't delete any data, but please make sure that you do that. Yeah, you have any doubts, guys, until now? No doubts? Okay, fine. So sharing my screen. Are you all able to see my screen?
Yes, sir.
Great. Okay. So we'll start with a few concepts about Linux, and then we will get into the practicals. Okay. So why should you learn about Linux? That's a very important question. So Linux is the base operating system for all kinds of electronic devices that you see and use today. Okay. So be it inside a data center or be it outside a data center, it doesn't matter. Okay. And hence, if you learn Linux well and if you get a good command and grip of how to work with Linux, okay, at least at the base level, you can build on that knowledge, and you can learn any new technology also very well and very quickly. Okay. So what are some of the examples? So uh, anything, your tablets, your phones, your switches, your Wi-Fi routers, your access points, inside the data center, large servers, supercomputers, okay, clouds, Amazon, Google, Microsoft, everyone uses Linux as the base operating system, okay, or some flavor of Linux or Unix as the base operating system, okay. And every other data center technology is kind of built by taking Linux as the core. Okay. Now, Microsoft realized that in order to make Microsoft Windows more popular than Linux, it has to be more convenient and easily available. So, long ago, the famous Mr. Bill Gates, what he did was he first started giving it for free. They themselves released pirated versions of Windows and gave it to all of us so that we get used to working with Windows so much that once we become IT professionals, the first operating system that we want to choose or want to work with is Windows. It's very unfortunate that it so happened, but that was a great marketing strategy by Microsoft and it worked. But even then, the most critical data center workloads are run on Linux or versions of Unix. Even today, when we talk about IoT, Internet of Things, which is nothing but all our regular things like our TV, our refrigerator, our e-scooters and e-vehicles, our washing machines, everything getting connected to the internet, right? Even those machines for controlling the devices and everything, they use some version of Unix or Linux inside. Okay, so hence it you need to learn this technology well. What makes Linux, so great is these few things, right? First thing is it's open source. Okay. Now you need to understand this word very well. Open source. Okay. What exactly is meant by open source? You all have done graduation or some kind of, BE or BTech, right? While you're doing that, you would have learned programming languages. And you know that these programming languages like Java, C, C++, okay, VC or VC sharp, Python, R, okay, all these programming languages are used to develop what? Are used to develop applications, correct? And when you are using such a programming language to develop applications to be used only by a specific company, and your code that you have written, the thousands or millions of lines of code that you all may have written, it will generally not be available to the public, right? They can't see what is being, how the software is working internally. That you would know as a software developer, you would know as the programmer. Okay. And hence, those all kinds of applications or software are called closed source software. Closed source means the source code that is used to write these applications, programs, anything. Okay. Like what I'm doing right now, Adobe Acrobat Reader I'm using. That's a program, that's a software. Your Microsoft Word, Microsoft Excel, all those are programs or software, right? And some kind of a code was used to build that software, okay, to give you the look and feel that you have. All those are called closed source. Okay. But apart from closed source software, there is a whole new world. I will not say new, but there is a whole different world called as open source software. Now, what do these open source software mean? It means the source code used to develop that software is available for free for anyone to use it the way they want it, and they don't have to pay a single rupee to use that source code. Okay, does that make sense? Open source means the source code that was used to develop the software is available for free, and you can use it for educational purposes, for anything else. If you want to build some add-on modules or software on top of it, everything is possible. Okay, but that source code is available for free. You can use it the way you want it. Okay, so Linux or versions of Unix that was actually born in AT&T labs way back about 40-50 years back. Okay, it's all open source. That means the source code is available for free. If you are smart enough, you can download that source code and use it the way you want it. Okay. Another important factor about Linux or Unix is it is not as visually appealing as Windows. Okay. Where it is very easy for a user to operate Windows, isn't it? You just go click, 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 click. That's it. Very little amount of typing you have to do on the keyboard in order to operate Windows. Okay. But when it comes to Unix or Linux, most of the work is done by using command line. What do we mean by command line? You have to literally type the commands, which means you'll have to remember which command is used for what. Okay. Don't worry, there are ways of easily remembering the commands, and there are ways to get help about the commands. And these are all the things that I'm going to teach you. Okay, how to very easily remember the commands, how to ensure that you understand what that command is going to do, how to see some examples, how to practice these commands. Everything I'm going to teach you. Okay, so don't worry about it. And the best part about having everything in the form of commands is it is scriptable. You see this word, it is scriptable. Scriptable means you can automate. You can write things called as shell scripts, which will help you automate certain mundane tasks. Okay, certain tasks which are repeatable in nature. Similar to how you would have learnt in your graduation, in your college, right? How to write software programs using a programming language. Similarly, using the commands of Linux or Unix, you can actually write programs on operating systems which can automate a lot of tasks. Okay, and hence it's very powerful and it is very scriptable. The third important characteristic of uh, Linux or Unix operating system is it is modular in nature. Okay, what do we mean by modular? Just like a modular kitchen, right? You build certain core components. Okay, and those core components will be same across multiple versions, and based on specific needs you can build modules on top of it which will interact with the core component. Okay, and you can achieve the functionality that you want. Okay, so it is very modular in nature, and that is what the whole world does. Okay, they take this core component because open source, the source code is available for free, and then they use their scripting knowledge and expertise, their knowledge on programming systems to build add-on modules, okay, around this core component. Okay, and give it their own shape, their own name, their own form. Okay, the best example that I can give you is Android. We all know that Android is an operating system built by Google. But if you go and ask the Google engineers, have you built that entire Android operating system from scratch? The answer is no. The core component of Android is still Unix or Linux. It's called FreeBSD Unix. Okay. And what Google has smartly done, since the source code is available for free, they have taken that FreeBSD Unix core component and they have built modules around it and given it their own shape, name, and form, and using it for a different purpose, which is called as running the mobile. Okay, and they gave it a name Android operating system. But ultimately, inside it is the core is Unix or Linux. Same with the Mac machine that I'm using. Do you think Apple built the entire source code of this Mac OS from scratch? No, they did not. Okay, the core of Mac OS is also a version of Unix, FreeBSD Unix, since it was open source, it was available for free. They used it, the core component, and they built their own software modules around it, given it their own shape, name, and form, and selling it to all of us as Mac OS or iOS. Okay, so these are very good examples of how Unix is being used. Okay, we have a gentleman amongst us who works at a big company, okay, known for its networking equipment. Okay, now that networking equipment also has some kind of an operating system inside. Any guesses what is the core component of that operating system? Again, Unix. Okay, so that company has taken this open source Unix, created their own modules around it, selling it with their own brand name in the market. Okay, so that is what people do. Even though open source is free, we have to conform to two kinds of licenses. One is called as copyleft licenses. Okay, and second one is called as permissive licenses. Okay, so what are these two? Copyleft licenses means you are not going to make any major change to the core component, and you will leave that open source code continue to be open. That means continue for others to still use it, okay, the way they want it. Okay, whereas permissive licenses are for specific purpose. Okay, like they will take a permissive license and they will add their own versions on top of it and probably sell it or reuse it in a completely different form or way. The examples that I gave you, right? Android, Mac OS, or Cisco, and all these people, they use permissive licenses. Okay, so they just take the source code and they will use it the way they want it by creating the wrappers around it. All right, so that's the difference. Now you don't have to go a lot of detail into it, just understand what do they mean, that's all. In most of our classes, what we will learn when we learn about Unix and other open source technologies, we will be learning about this variant of open source software, copyleft. That means we will be using the open source. Everybody else in the world also will be using the same open source. Okay, so no difference. So whatever you learn in these classes will be valid across the globe. Okay, no worries. And hence, boys and girls, whatever you learn in these classes, and once you get some level of mastery on these subjects and technologies, you can apply for jobs not just in India but outside India also. Okay, because it's the same technology. Now, who develops this open source software? Okay, well, Red Hat is a very big contributor, definitely, but they are not the only ones. Okay, and as you can see, it's an army of volunteers. Okay, which means it's general public like you, me, or some people you who think that source code should not be kept in a few arms. Okay, they want to distribute it for free, so that's their mindset. And that is where they contribute. So whenever they think, okay, there is a bug here, or this can be improved, performance can be improved. They only will write the code and they will release it in the public for everyone to use. Okay, so there are a lot of engineers within Red Hat, and within all these companies that you see, you have Intel, you have Google, you have Samsung, you have IBM, then you have SUSE Linux, you have Oracle, Broadcom, Qualcomm. All these companies do their own contributions into the open source community. Okay, depending upon their interests and depending upon the interests of the coders, okay, in those companies. All right, and they form a community and they release the source code. Where do they release it? You would have seen this portal called GitHub. Okay, so GitHub is a place where you can see lot of source code. Okay, and most of the open source people, they will post their source code here in GitHub. Okay, and as you can see, so many companies use GitHub to get their source code from open source software. Okay, so for example, if I want to search where is Red Hat's source code for Linux. Okay, so we have hit a snag, but you can do that. Okay, you can search for source code in GitHub. So for example, here, so as you can see, their APIs, the code, okay, QL code language, all is here. And you can see how many people have used it, how many people have downloaded, and you can see the contributor here is MIT. All of you know what MIT stands for? Massachusetts Institute of Technology, based in Boston, USA. One of the world's premier research and tech institute. Okay, so even they are contributing to open source using GitHub like this. They can post it in their own website also, but they do it here. Okay, so it's called GitHub. Git, G-I-T, Git, H-U-B, Hub, GitHub. You can see a lot of projects. You can see pre-built packages. Okay, so we will learn a little bit about these later. Okay, not now. But you get the point, right? The point is you can use it. Now, here we see one more word, okay, called as kernel. Anybody can tell me what a kernel is? Anybody? What exactly is a kernel?
The hardware.
Sorry?
Hardware.
Kernel, no, kernel is not hardware. It's
It is
actually
a base of the operating system.
correct, correct, correct. Who was that?
Hari.
Hari. Good, Hari. Yes. Kernel is the base of an operating system. Okay. You see this diagram here. Okay. We all learned this diagram, and instead of the word kernel, we learned that operating system does this job. Okay. Which is an interactive layer between the hardware and the programs that run on our laptops. The best example that we all learned was these MS Word, Excel, these are all applications. They speak to the operating system called Windows, and that's how they get access to CPU, memory devices, and all the hardware. But within the operating system, there are sub components, okay? And the core component, which actually gives the core functionality of any operating system, is called the kernel, okay? Kernel, Kernel, okay? Very important word, kernel. Why? Every operating system has its own kernel, and the operating system's version is defined or identified using on which kernel it is running or which kernel it is using. Okay, so you will hear this word kernel time and again, okay, going forward. Every time anybody talks about, hey, which OS are you using? You will say, oh, I'm using Red Hat 8. The immediate next question will be, which kernel? And you should be able to tell, okay, this is the exact kernel I am using. Okay, or this is the exact kernel that is being installed on this particular server or machine. Okay, so this word kernel is very, very important. We don't have to go into details of what a kernel does, just we will understand what a kernel is. That's all. All right. Now, a little bit of a background on what Red Hat is. So Red Hat is world's leading provider of open source software, and it is their software is used in cloud, in middleware, in storage, in virtualization. I mean, you can take any kind of a machine, more or less, it will have some version of Linux in it. Now, whenever we are talking about Linux, okay, we talk about something called as a Linux distribution, which is nothing but in the core which kernel it is using. Based on the kernel version, okay, the Linux distribution changes. Okay, so this is typically how an open source project flows. So we'll have, as we have seen on GitHub and various other platforms are there, they create small projects. So this kernel, what you're seeing or hearing right now, would have started as one small project way back in some lab. Okay, then people find it very useful. They start integrating it with different modules and different hardware, different other software. Okay, then it becomes a platform. And then once a company like Red Hat starts owning that source code, making sure that it is tested, it has no bugs, okay, it performs well as expected, okay, all that, then it becomes a platform, okay, complete platform like Red Hat, and it becomes a stable distribution. Okay, so one of the distributions is called Fedora. Okay, Fedora core kernel. Based on this Fedora core kernel, lot of distributions of Linux are available in the world. Okay, so my Red Hat, is a big contributor to this Fedora kernel. And generally, what happens is every 6 months they will release one update for this kernel based on the needs of the customers and based on new technologies that are coming in. Right? And Red Hat, as you can see, bases its major releases of Red Hat Linux on this Fedora kernel or the Fedora core itself. Okay. Okay. So now we will get into the little bit of practicals. Okay. So we will do this evaluation later. That's fine. Okay. Now we'll get into command line. Now, when we are talking about command line, you'll have to understand one thing, that particular module which is allowing you to run the commands to interact with the Linux Fedora core kernel. Okay, that module itself, again, it is open source only, but it is called a shell. Okay, that module which allows us to interact with the Linux or Unix operating system and its kernel, that module is called as a shell. This shell accepts the human readable command lines as inputs. It will work with the kernel in the backend, and it will generate outputs based on what you have asked it to do. That's the basic functionality of a shell. Okay. There are many kinds of shells available uh, in the world today, but the most popular one is called as bash. BASH, bash. And here you can see what is the full form of bash. It's called born again shell. Okay. So some of these contributors, they become very creative and they give a lot of creative names. You will see names from Star Wars. You will see names of some planets and all being used. Okay. This movie, Jason Bourne, okay, where Matt Damon was the hero, that came from this only. Okay. So it's called bash shell. Now, what we are going to do is we are going to see how a bash shell looks like and what kind of commands we can start using. So the moment you log in to any Unix system after giving the user ID and password, you will see a prompt like this. That's called a prompt. And at the beginning of the prompt, you will see a dollar symbol. Okay. Doesn't mean that you're going to get any money. Okay. It is just a symbolic representation that, okay, from here you can start typing your commands. Okay. And it is called as a shell prompt, right? In some versions of Unix, this dollar may be replaced by a hash. Okay. But ultimately, it's the same thing. But within Unix terms, if you are seeing this dollar, it means that you are a lower level user. If you are seeing this hash, it means that you are a super user. Okay. You're logged in as a super user or the ultimate admin. And you can see that here. Whenever you have a dollar symbol, you will see the username here. Okay. At host, what is the host name? Host name is nothing but the identity of that computer. Okay. Whereas when you see a hash symbol here, you will see root. Always remember, for any Unix system, the super user is root. Okay. The super user for any Unix system is root. Anybody has the root password for that system, they can create havoc or they can do good things also. Okay. So super user is root. Now, how do we get into a Unix bash shell? Let me show you. Anybody who is using a Mac system, they can go into something called as terminal. Okay. You just type the word terminal and such kind of a command prompt opens up. Okay. I'm not sure if you're able to see it clearly. So this is the command prompt of Mac OS. Okay. So that Unix kernel that is used to run this operating system, that operating system is something that can be accessed here like this. Okay. Just a minute. Now, for all of you, you might be using Windows system. Now, how do you get a look and feel of this? I'll show you. So you go to your browser, okay, Chrome, Safari, anything, and type this website named Killer Coda. Okay, Killer, Killer, Koda, Coda, Killer Coda. Okay, in this Killer Coda, it will actually give you something called as playgrounds. Okay, and you can see a lot of playgrounds here. But before you can use any playground, you have to log in. So I'm using my normal Google login itself. So this kind of security, what we are doing right now, can anybody tell me what kind of security is this? to access any web portal, if you're using your social media password, user account and password, what kind of security is this called? Anybody? This kind of security is called as SAML, SAML, SAML authentication. Okay, SAML, SAML authentication, which means an existing program or a web portal is using your social media accounts like your Facebook account, LinkedIn account, Google account, Mac account, or your email ID to allow you access into their web portal. That's called as social media authentication. And technical term is SAML, SAML, SAML. There are various versions, okay, but it allows you to do this. Now you will see one more security concept. With the moment I entered my user ID and then password, it is asking for it will ask for something else. You see here, this is called an advanced security feature called multi-factor authentication, MFA, multi-factor authentication, MFA. Okay. And today in our world where cyber attacks and all are really, really prevalent, just user ID and password is not enough. Okay. You will need another layer of authentication, and that another layer of authentication is called as multi-factor authentication. So one factor was passwords, user ID and password, and then one more layer like a captcha, like entering OTP, like doing some action on an app in another device, okay, or speaking something, or sometimes Google says identify where roads are there, identify where cycles are there in these pictures. All that are examples of multi-factor authentication, okay, which means you're not just dependent on passwords for security, you are going one level higher. Now you can go multiple levels, but then the user gets a little pissed off and hence they stop at one level other than password. So it's called multi-factor authentication. Now once you go to this killer coda, you can go to these playgrounds, and remember it will give you only 1 hour access, okay, at a time. So don't refresh your browser, don't leave it open. This time is extremely valuable for you. So until such time that we install Proxmox to make your laptop itself, okay, as your lab, you can use this killer coda, okay. And see, it is using a version of Ubuntu. Now, what is Ubuntu? It is nothing but Unix, okay. You don't have to worry about it. It is nothing but Unix. And you see here, what prompt am I getting? I am getting dollar prompt. Dollar means what? I'm a sub user. Okay. I'm not the super user here. Okay. Now, what is the command to go into a super user? Very simple. Super user. Super user. The moment you enter super user, it will try to go into the super user prompt. But unfortunately, this playground will not allow you to do that. Otherwise, you will break into their system. So they will not allow you to go into super user. So your prompt will remain dollar. But that's okay. That's okay. Later, once we install Proxmox on your laptops, you will be able to get into super user. But the simple command is SU, super user. SU stands for super user. Now, for any command, okay, in Linux or Unix, you want to get help, okay, you want to understand more details about that command, you have to do something called as man, okay. What does man stand for? Nothing but manual pages, okay. Like how for every device we have certain guides, right? Like when you buy a TV, you get a brochure along with the TV, how to operate the TV, how to install it, how to do remote control. Okay. Everything about the TV you will get in that manual, correct? It's called a manual, TV operating manual. Okay. Similarly, when you buy a phone, you get a manual. When you buy a laptop, you get a manual. Similarly, for every command in Unix, okay, there is a pre-built manual for it. And the short form for manual, man. Okay, the short form for a manual in Unix or Linux is man. So to understand the details of any command in Linux, all you have to write is man and that command. Now the command that I used was su, right? Super user. So all you have to do is just enter that. See, as you know, as you can see here, it will give you all the details about that particular command. Okay. It will tell you what is the name of the command. Okay. It will tell you the syntax of the command. Syntax means how to use it. So you have to write su, then you have to leave a space, then you can give some options, then you can give a hyphen, and then you can specify a username and you can give some arguments. Okay. So this is called as a syntax, or it's also called a synopsis. And then it gives you a complete description about that particular command. Okay. Which shell it supports. Okay. What are the various values of that particular option, what exactly does it do. Okay. Everything. And here you can see options, right? Now you need to know which option does what. So all those things are given here. Okay, if you put minus C option, this is what it will do. If you put minus F option, this is what it will do. If you put minus G, this is what it will do. Like that. Okay. For every command like this in Unix, you will have something called as a man page. It is called as a man page, manual page. Okay. And the man page of that particular command is going to give you complete details about the command. You don't have to remember anything. Okay. Just understand how to read this man page, how to read this manual for that command. That's it. Okay. You don't need anything else. All right. It will also tell you that if you're using this command in a script, okay, what is the output and error codes it returns. So all this also is something that it will give, so that when you're writing any program based on this particular command, what is the error code it generates, so on and so forth. And you can also see where is the executable code for this command, in which path. Now this is important. Okay, this is very important. Now I will tell you a little bit about this. And what I want you to do as a lab practice today is, what is the equivalent of all this in Windows? You will have to do in your laptop. Okay. Not the command line, but just by clicking. Okay. So when I press Q, okay, you will come out of that man page. Okay. So in one of our previous classes in the basic course, we understood about what exactly is a file system. Okay. So that is why I will not go into the depths of what exactly is a file system right now. Okay. You will have to go through that one of the previous windows. We have explained in detail what exactly is a file system. Now we know that a file system is basically the layer of the operating system which will tell the operating system how data is placed inside the storage medium, like the hard disk or the SSD. In our basic class, we also explained what is a hard disk, what is SSD, what are the basic differences between them. All that has been explained in the basic course. So please do refer to those modules in the basic course. Okay. But eventually, every file system will have something called as a hierarchy. Okay. What exactly is a hierarchy? A hierarchy is a top-down approach on placing the data inside the file system. Okay. A hierarchy means placing the data inside the file system. Now, we all know hierarchy, right? We have hierarchy in our families also, right? So there is a head of the family, then there are people who work with the head of the family, and then there are children, middle-aged people, okay, so on and so forth. Similarly, in a company, we have the C-level executives, the board, then we have the directors, then we have the managers, then we have the team leads, then we have engineers, so on and so forth. So that's called a hierarchy, right? Similarly, in a file system also, you will have something called as a hierarchy. And every hierarchy starts with something called as a root. Okay. And this is a perfect picture of a hierarchy. Okay. And if you see here, this is the hierarchy of a Unix file system. Okay. These are all the pre-built folders where data and modules and structures are going to be stored. All right. You will know exactly in which folder what is there, right? So this is how the hierarchy of a Unix system will look like. And here you see which year what was developed. So the technology that we are learning is not latest, but still it forms the base for everything that we are doing today in IT and data centers. Okay. And here it also shows you which modules are open source and which modules are closed source. Okay. And which are mixed means some parts are open source and some parts are closed source. So as you can see, HPUX is a variant of Linux which is closed source, operated only by HP. Then we have Solaris, which is by Sun Microsystems, acquired by Oracle. Okay. Then we have AIX. AIX is a version of Unix. Okay. Core is open source, but they have built modules on it, made it closed source by IBM. Then we have SCO Unix. Okay. Then we have this Sun operating system, which gave birth to Solaris. Okay. Then, if you see here, this is completely open source, OpenBSD and FreeBSD, which I was telling you about. Okay, see here, FreeBSD. So this FreeBSD actually has given birth to, God knows how many versions of Unix. Okay, so all these are open source. And if you see here, Mac OS, the very machine that I am using right now, it has also come from open source FreeBSD only. Okay, and all the Sequoia, Darwin, okay, all these Mac OS versions, they have come from open source operating systems only. Okay, and then you have Red Hat Linux. Red Hat Linux, some versions are open source, but some versions are there which are closed source. Okay, so we'll discuss them later. But this shows you the hierarchy and the file system hierarchy. It starts from something called as root. Okay, this and the root is defined by this symbol. Okay, forward slash. So wherever you see forward slash, it means that you are in the root directory of that particular operating system on that particular machine. Okay, you are in the root directory of that particular operating system on that particular machine. Under the root directory, you will have lot of subdirectories. So these are all subdirectories. Bin stands for binaries. Boot stands from where the operating system is going to be booted up. Okay. Then dev stands for device files. So all the device drivers like your Wi-Fi adapter, like your network card, like your display with the screen, like your camera, like your USB, like your hard disk, your SSD, everything is a device in Unix. Okay. And all those devices and their respective drivers are going to be stored in this subfolder called as dev/dev. Okay. And each device is going to have its own identification, and we will go into that later. Okay. And then you have one more very important directory under the root called as etc. Okay, etc actually comes from this word called etc. Okay, but the developers of Unix did not find a better name because they already had used these names binary, boot, dev. So everything else, okay, like configuration files, okay, uh, rules, okay, everything they stored in this folder called /etc. Okay, so whenever you will see that you're creating a new module or you're installing a new software or a new program or new module on Linux or Unix, you will see that part of it is stored in /etc and part of it is stored in /bin, which is nothing but the binary. Okay, and then the optional packages comes under /opt, and then you have all these other uh, subdirectories in it. As and when we learn about various things in Linux and Unix, we will understand what each of these directory means, what does it store at a high level, because this is intermediate course, this is not advanced. We will only scratch the surface, and as and when we get into more details, we will see what each of these directories mean and where to look for to troubleshoot any particular issue. But basically, I hope you all understand what directory structure Unix follows. Any questions or doubts till now? Okay. Any questions? Any doubts? No? Okay, fine. Now, how will you know that you are in which directory? Because in Windows, you will know, right? So once you click on a folder, you can see it on the top that, okay, you are in this particular folder, then you will see all the files in it. Okay. But in Unix, how to know? Okay, very simple. The first command is pwd. This is not Public Works Department. Okay. PWD. PWD stands
But
for
current working
present working directory. Correct, correct. Present working directory. So you see, all these Unix commands are coming from normal English words only. So if you understand the meaning of the command and you know what you want to do, okay, it will not take major effort from your side to remember these commands. Okay, it is very, very easy. So you see here, the moment I typed pwd, it says, okay, we are in the root directory of this particular machine. Those is a virtual machine. Still, okay, we are in a shell. The shell's name is Ubuntu. Okay, it is, we are in the root directory, present working directory. Okay, now how do you know what all directories are there in this particular system? Very simple. Suppose you want a list. Okay, so list is what comes to your mind, right? So in Unix, the command is also simple, list, but short form, ls. Okay, list. Ls stands for list. Okay, so it says that there is only one directory in this /root, which is called as file system. Okay, but I want to know a little bit more about this directory. Like in Windows, you right click on a directory and go to properties, you will see a lot of details about that directory, isn't it? Like what is the size of the directory, when was it created, okay, who created it, whether we have the permissions, read permissions, write permissions onto that directory. Now, similarly, I want to do something and I want to see more information about this directory in Unix. So I will say list all. A stands for all. Okay. List hyphen A. All. Give me all the details about this. So then you can see we have hidden directories also. Anything with dot in Unix, it is hidden. Okay. It will not be visible. And then you will see, okay, these are all the directories. And then we have this file system directory. Okay. And there is one more option, AL. Then I can see like this, in this way. Now you see, I can see which is the root directory. Dot means current directory. Dot dot means previous directory. Okay. Who created it? This user called root created it. Okay. How many subdirectories are there in it? 22. Okay. What is the size? This is the size in bytes. 4096 bytes. This is 10 bytes. This is 3194 bytes. This is 161 bytes. This file system is just 1 byte. Okay. When was it created? You see here, this root directory was created on May 7 today because I started it. Okay. And it shows the time also. So it is not India time. This is of some other time zone. Okay. Uh, and then, but this, its parent directory, dot dot its parent directory. Parent directory was created on April 28th itself. Okay. So which means I'm using a sub portion of something larger. And if you see, this bash shell has its own directories, history, okay, and all that. So those are occupying so much space, and these were created even before. Okay, so this parent machine was actually created in February 10th. So like this, we'll get a lot of details, okay, about this respective directories. Okay, and this shows, okay, this is the file system directory what we got in ls, and it shows there are a total of 40 directories in this particular system. Okay, and later we will see what these symbols mean. Okay, what these symbols mean we will understand later. For now, you remember just one thing. Okay, d, the first letter, just focus on this first letter. Okay, just focus on this first letter. If you see the first letter as d, that means it's a directory. Okay, if you see the first letter as d, this is a directory. Okay, so how many directories are there here in the system? 4. 1, 2, 3, and 4. Okay, 4 directories are there. Then if you don't see anything, it's a blank. So the hyphen means a blank. Okay, there is nothing, no letter mentioned here. Okay, it's a blank. That means it's a file. It's not a directory, it's a file. Okay, see, this is a file. This is a file. This is a file. This is also a file. But this is a directory. This is again a directory. Okay, see, D is written in front of it. And you will see the directories mostly will be in different color and they will be in bold. Okay, so even from the way you see it, the way it's visible on the system here, from there also you can make out that it's a directory or a file. Okay, and of course you can see it here. All right, then we see one more thing. L. What does L stand for? L stands for link. It's called a link. Okay, now what exactly is a link we'll see later, but in Windows you create things called shortcuts, so for example, if there is a folder which you want on your desktop and you want to access it just in one click instead of going to top level, then down level folder, and then going to your file, you want to create a shortcut, right, on your desktop. So what you will do, you'll just right click on the file and say create shortcut on desktop in Windows, right? Exactly the same thing. If you want to do it in Linux or Unix, you will create something called as a link. Okay, and if you see here, this folder called file system is neither a file nor a directory. Okay, but it is a link. That's why the letter L is written in front of it. And it is also telling us that this link is referring to what? Okay, this arrow, and it is referring to what? What does this symbol mean in Linux or Unix? We all learned a little while back. What does this symbol mean? The forward slash.
Root.
Yes, correct. It's the root. So what this machine user, the administrator, has done is he has created a shortcut for the root. Okay. And he has given the name of the shortcut as a file system. So whenever we are running any command on this link or shortcut called file system, that command is actually applicable directly on this root. Okay. And if you see here, now you will get a little bit of idea about what these letters mean. Okay. You will see these three combinations only: R, W, X. R, W, X. Okay. These are not some Egyptian code words. Okay. Again, very simple. These are called file permissions. Okay. These permissions are, are defined by these three letters. Okay. The letter R stands for read, the letter W stands for write, and the letter X stands for execute. Okay. RWX, read, write, execute. Okay. But now, why are there these three RWX and three times it has been written here? Because in Unix or Linux, this first set of these three letters represents user. Okay, the current user. So in our case, who is the user that is logged into the system right now? This guy, Ubuntu. Okay, the name of this user is Ubuntu. Okay, so this three letters will tell us that this user Ubuntu has got read, write, and execute permissions on this particular file or link called as file system. Okay, read, write, and execute permissions on this particular file called as the file system. Okay, then who are these two gentlemen? Okay, or who are these two ladies? Okay, this guy, okay, the middle guy is representing the group. Okay, is representing group. As you know, in computer systems, users can be grouped together. Like administrators is one group, backup guys is one group. Okay, read only guys is one group. Like that, you can group users together and form a bunch. Okay, now this second uh, set of letters is representing the permissions of the group of which this user Ubuntu is a part of. Okay, because every user will be a part of certain group. Okay, and this three letters tells us that whichever group this user Ubuntu is part of, okay, every user in that group apart from Ubuntu also has read, write, and execute permission on this particular file or a link called as the file system. Okay, so once again, these set of 9 letters actually define what level of permissions are there on this particular file or directory. Okay, the first three represent the user, and the user can be seen in the prompt called as Ubuntu. The second set is for the group of which the user is part of. Then what about this third thing? The third thing is others. Okay, others. Others means any other user who is logging into the system. Okay, either remotely, okay, or by anybody else. That what level of permission does that user have on this particular file or link or directory. Okay, now boys and girls, tell me about this particular set of permissions. What does this say? Do others have write and execute permission on this particular file? Do they? What do we see here? We see only letter R. The others are blank, right? Which means any other user who is logging into the system can only read this file. They cannot write into it, which means they cannot modify it, nor can they execute it. Okay. In Windows, how do you execute a file? You just double click it, right?
Here you write a command. You write sh, which is shell, and you execute a file in Unix. Okay, so you cannot run it. You can only read what are the contents of that file. That's it. You cannot do anything else. How about the group? The group also same. They any other user apart from Ubuntu, okay, has only read only permission on this file. They cannot modify the file. They cannot run or execute that file. Okay. And but how about this user Ubuntu? This Ubuntu user can read this file and write this file, but cannot execute this file. Okay, this X is missing here. It's written as a blank. Okay, this user Ubuntu cannot execute this file. Okay. Now let us come to this combination here. This is a directory. It's not a file. Okay. What can Ubuntu do? This current user, he can read the file directory. You can write into the directory, that means create new directories or create new files, and also execute the directory, make this directory part of a command. Okay. Whereas other users in the same group as Ubuntu can read the file, cannot do any modification on that file, write is blank, cannot or can execute, okay, the file. Others can read, cannot write, can execute. So this is how you will read these permissions. Okay. Any questions or doubts on this?
No, sir.
Great. Anybody else? Any questions, doubts? Is it too complicated? Is it getting too difficult?
Yes, sir. I missed that one, sir. First, RWX is for user,
For
current user,
user, yeah.
and
This is
then
for
group.
user, then
Okay,
group, and the third one is others.
others. Okay, okay.
Others. Okay. Now, when you are at this dollar prompt, okay, how will you know which user are you? Very simple. Who am I? So it says your root. Okay. PWD means where am I? I am at this hierarchy called root in a subfolder called root. Okay. Now suppose I want to, you know, create a file, go to a different directory and all that. So that I will be giving you as lab exercises today. Okay. And you can just log into this particular website called killercoda.com. Okay. 1 second, let me move this thing. Okay. You see this website, killercoda.com. I'll put it in the chat as well. And whatever lab exercises I give you on Unix today, you can execute it here in this website called killercoda.com. Okay. Under killercoda.com, you have to go to playgrounds, go to the scenario and go to Ubuntu. Then you'll get the same page like this. Okay. And just give me some time. Whatever is the recording of this video, I'll be uploading it on YouTube in my channel, and I'll share the link with you all. All right. So that you can refer to the class and do your practice also. Suppose you don't understand anything. Okay. All right. Any more questions? Any more questions? Any doubts?
No, sir.
Samsura, you have any questions? Any doubts?
No.
Okay. Okay. Because you raised your hand, so that's why I thought. All right. So thank you, boys and girls, for your time today. I hope you're finding this useful. And people who have attended the basic course now will understand, okay, we are taking a notch higher. We are getting into, hands-on practical details. It's not just theory anymore. And the more you practice, the better you become at it. There is absolutely no other way. There is no magic wand. There is no secret. Okay. The more you practice, the better you become at this. It's a very simple, fundamental way. Okay. And initially, when you're doing stuff in Killer Coda, don't think that anything will go wrong by if you type something else. Let it go wrong. No problem. Okay. Don't be afraid. In this phase, when you're practicing in a lab environment, don't be afraid of trying new things. Okay. Whatever comes to your mind as an imagination. Okay. Let me try this. Let me see how this works. Let me find out different commands. Okay. All of that, go ahead and practice. And any doubts you get while doing such kind of crazy practice, no problem. Please come and ask in the group. We will do our best to answer you. But don't shy away from trying new things, and don't think that whatever lab is given, only that much is for the day. Okay. If you want to go beyond, if you want to do 2 3 labs at once, okay, go ahead, do it, no problem. But don't disturb the other people in the class when you come in tomorrow, because they may not be as quick as you. All right. Everybody has their own learning curve, so let us give everybody a chance to learn along with us. But if you are, really excited, want to do many things at once, please go ahead, no problem. Right. Okay, so we have come to the end of class 1. Thank you so much for your time. We will meet again at the same time tomorrow with new concepts on Linux and Unix. Thank you. Bye bye. Have a nice day.